Han-Jin Lee from KRISO, Korea. In this presentation, I will introduce the status of decarbonization and the digitalization projects in Korea, especially my company KRISO. A month ago, the result of the Working Group 1 for IPCC Intergovernmental Panel of Climate Change's 6th assessment reports were announced. The report is about the physical science basis of climate change. This report assesses the climate response to 5 illustrative scenarios of climate change. They started in 2015. In the figure, the 2 scenarios are about high-end. For example, the 2 scenarios are high-end and very high GHG, greenhouse gas, and CO2 emissions that roughly double from current level by 2100 and 2050, respectively. In the table, compared to 1850 to 1900, the global surface temperature average over 2081 to 2100 is likely to be higher by about 1.4 degrees Celsius under the very low greenhouse gas emissions scenario, by 2.7 in the intermediate scenario, and by 4.4 degrees under the very high GHG emission scenario. Almost every nation on Earth signed up to the goals of the Paris Climate Agreement in 2015. This agreement aims to keep the rising global temperature below 2 degrees Celsius this century, and pursue efforts to keep it under 1.5 degrees. But this new report says that under almost all emissions scenarios, both targets will be broken this century unless huge carbon cut occurs. The figure on the right shows the outlook for maritime ship emissions compared to 2008. In several long-term scenarios, emissions are projected to increase from about 90% of 2008 emissions in 2018 to up to 130% emissions by 2050. Shipping today is experiencing increasing pressure to decarbonize its operations and to reduce emissions to the air. In April 2018, the IALA adopted an ambitious GHG reduction strategy with a vision to decarbonize shipping as soon as possible within this century. With 2008 as a baseline year, this strategy aims to reduce at least 50% of total GHG emissions from shipping by 2050. At the same time, it also aims to reduce the average carbon intensity by at least 40% by 2030 and 70% before mid-century. MEPC 72 adopted the resolution, Initial IMO Strategy on Reduction of GHG Emissions from Ships. This initial strategy identifies that a program of follow-up actions of the initial strategy should be developed. The program of follow-up actions include 8 streams of activity. The table shows the 8 streams of activities. The table on the screen shows the action plan through 2023 for the 8 streams of activity. At the MEPC 76 in June of this year, guidelines for implementing short-term measures to reduce carbon intensity indicators were adopted. Mid to long-term measures to reduce GHG emissions from ships were discussed too. The short-term measures aims to achieve the target set in the IMO initial GHG strategy to reduce the carbon intensity of all ships by 40% by 2030. IMO requires all ships to calculate their Energy Efficiency Existing Ship Index, EEXI, and establish their annual operational carbon intensity indicator, CII, and the CII rating. In other words, ships get a rating of their energy efficiency A, B, C, D, and E. A ship running on a low carbon fuel gets higher ratings than one running on fossil fuel. There are many things a ship can do to improve its rating through various measures. They are full cleaning to reduce drag, speed optimization, low energy light bulbs, solar or wind auxiliary power to accommodation services, etc. The key to achieving emissions reduction is developing, maturing, and scaling up solutions to a level where the cost is acceptable. Technical and operational measures can achieve a significant GHG reduction, but up to 100% GHG reduction can only be achieved with alternative fuels. In the short term, equipment that improve energy efficiency can be used. However, ultimately, low-carbon fuels such as LNG, methanol, and carbon-free fuels such as ammonia, hydrogen are inevitable to satisfy the IMO's GHG reduction measures. From 2023, existing ships will be subject to EEXI and CII regulations. EEXI should be calculated for ships of 400 gross tons and above under the different value set for ship types and size categories. EEXI indicates the energy efficiency of a ship compared to a baseline. CII, carbon intensity indicator, determines the annual reduction factor required to improve the ship's operational carbon intensity continuously. The actual annual operational CII achieved must be documented and verified against the required annual operational CII. This determines the operational carbon intensity rating of the vessel. The performance level would be recorded in the ship's Ship Energy Efficiency Management Plan, SEEMP. A ship rated D for 3 consecutive years, or E, would have to submit a corrective action plan to show how to achieve the index C or above. To minimize GHG reduction from ships, conventional technology should be combined with alternative fuels and power systems. KRISO, my company, is researching the development and the demonstration of energy efficiency improvement devices through simulation and model testing to respond to this situation. Recently, the scope of research is being expanded to include eco-friendly alternative fuel propulsion systems, such as ammonia and electric batteries and so on. Due to the limitation of existing GHG reduction technology, it is inevitable to use alternative fuels and power systems. To respond to IMO environmental regulations, next generation ship propulsion systems will be very diverse. It is expected that optimal solution will vary depending on the size and the type of vessels. KRISO is researching optimal fuels and propulsion system configurations for small coastal ships and large offshore ships, respectively. The major technologies for reducing GHG emissions from ships currently being researched by KRISO are divided into 3 parts. The first about the propulsion technology of eco-friendly alternative fuels. The second is about the configuration of the power system, operation status monitoring, and operation optimization technology. The last is about new hull form development and energy-saving devices. There are many types of eco-friendly alternative fuels, such as LNG, ammonia, hydrogen, and the battery were analyzed and summarized in the table. Now, fuel for vessels must be eco-friendly. Additionally, fuel supply, space utilization, and shipbuilding cost should be considered. This table summarizes the current state in consideration of the use of ammonia or hydrogen co-firing engines and the use of hybrid electric propulsion engines, and so on. The problem is the current level of technology, required space, and additional facilities, etc. Ammonia, hydrogen, and electric batteries have very low energy densities in terms of volume. So this means that the system size required to store the same energy increased. It is one of the important reasons why the optimal solutions should be different depending on the size and the type of vessel. There is not yet single solution, and various means will be mixed, I think. In many cases, it is expected to be used in conjunction with existing propulsion systems in hybrid form. From now on, I will introduce representative projects carried out or planned by KRISO, my company, related to decarbonization. The first is the development of an electric-powered car ferry funded by the Ministry of Oceans and Fisheries. The electrically propelled car ferry under construction runs 100 on electricity. This car ferry will utilize the removable power supply system, which means that ports don't need high voltage facility for direct charging. The system overcomes the challenges of the Korean coastal environment with a large tidal range and frequent flooding due to typhoons. In the removable battery system, a vehicle carrying the battery is loaded onto the car ferry, and the vehicle is connected to the car ferry. It provides electricity for propulsion and operations. It means that the battery system have fields to move. Upon its completion in 2022, the car ferry will enter the commercial market by 2023, following test sales, optimizations, etc. The total budget of this project is about $40 million. This project is about one-stop solution for eco-friendly ship propulsion engine testing. The objective of the project is the development of the integrated test platform. The platform will allow the testing and the verification of a wide range of ship propulsion engines, including electric and on-ship hydrogen power. The Korean government MOF is responding proactively to new maritime environmental regulations and emerging eco-friendly ship market with new legislation, such as the Act of Promoting the Development and the Distribution of Eco-Friendly Ships and the announcement of the 2030 Green Ship K strategy in 2020. The project to develop the eco-friendly ship test platform is part of the initiative. The budget of this project is about $30 million. Eco-friendly shipbuilding corporations and research institutions will be able to conduct cost-effective testing on their new technologies in this facility when the project is complete in 2025. Next year, a new large-scale eco-friendly ship development project will begin. The name of the project is Green Ship 3170. The Green Ship 3170 project supports the full cycle from eco-friendly ship technology development to its commercialization. The project includes eco-friendly ship key technology development, testing and evaluation technology development, offshore demonstration and operation data acquisition, standardization, and law and regulation improvement. The project aims to develop and commercialize technology to reduce GHG emissions from ships by 70% or more by 2031. So the name of project is 2031 3170 Green Ship. The total budget is about 200 million US dollars. Although the organization responsible for the project has not been decided yet, but KRISO plans to participate in some form. Now, so far I have only looked at projects related to decarbonization. From now on, I will introduce the content related to digitalization. Examples of digitalization for decarbonization can be broadly classified into three categories. The first example is about the current navigation technology. The digitalized smart ship will present the optimal operation condition to the navigator by pre-calculating the expected fuel consumption. Furthermore, through port-to-ship interaction, it is expected that it will be possible to identify the traffic situation at the target port in advance, and to present the optimum vessel speed to minimize the time and GHG emission at anchorage. Next, it will be possible to reduce GHG emissions by predicting routes that can minimize fuel consumption by using big data such as weather environment, engine performance, and ship traffic flow. Finally, various fuel combinations such as LNG, ammonia, hydrogen, and electric batteries will be used in future eco-friendly ships. Therefore, the ship's propulsion engine and the control system will be very complex to match that fuel. Through digitalization, new smart ships will be able to provide designers and navigators with much data for designing the eco-friendly fuel propulsion system and the optimal operation method after manufacturing. These digitalization smart ships are expected to contribute to decarbonization greatly. Digital services for ships that can be easily conceived include monitoring and managing smart ships and optimal route guidance for ships. The picture on the left shows the general situation of the smart ship monitoring service. This site is Hyundai Global Services Digital Innovation Center, mainly managing Hyundai Heavy Industries smart ships. The picture on the right side is an example of using the safe route guidance service developed by Smart Navigation. The picture is the result of the Smart Navigation development project. This service is for small vessels such as fishing boats and provide a safe route to avoid low water depths, dangerous objects, and the various no-go areas. Unlike the general weather routing service, it aims to secure the safety of small ships in Korean waters. However, I think the essence of digital transformation in ships is maritime autonomous surface ships, MAS. The Korean government also started the Korea Autonomous Surface Ships project in 2020. It was jointly funded by MOF and the Ministry of Trade, Industry, and Energy. The total budget is about 130 million US dollars. KRISO and the Korean Register formed the project office together. The project's objectives are the development of core technology of autonomous ships and laying the foundation for commercialization. This project plans to build a medium-sized merchant ship engaged in international voyage to test the performance of maritime autonomous surface ship. It is planned to operate the ship at IMO level 3 in the ocean and the level 2 on the coast. Of course, a project for the port digital transformation will also start next year. This project aims to develop an information chain between the ship information system, such as navigation, the port information system, and the hinterland information system to improve the efficiency of port logistics and to protect the environment in the port. The task is divided into 3 groups. The first is to collect the data needed to build the information chain and standardize the data format. The second group relates to reasoning missing links necessary to construct an information chain network using AI technologies such as deep learning. The final part is to develop a prototype to examine the effectiveness of the services. The total budget is about $12 million. KRISO plan to participate in this project as well. So far, it can be expected that this digitalization project will increase the operational efficiency of ships and ports, and that the result will lead to a reduction of GHG, greenhouse gas. However, digitalization projects that directly aims to reduce GHG at sea have not yet been carried out in Korea. Almost all digitalization project aims to increase efficiency. GHG reduction is an effect resulting from increased efficiency. Now, I think it is necessary to expand the scope of digitalization to include new decarbonization technology, as well as obtain GHG reduction effect from the result of digitalization projects. Most decarbonization projects aim to develop new propulsion systems using alternative fuels. For ships equipped with such a propulsion system to be commercialized, monitoring and maintenance service for complex eco-friendly propulsion system must be provided. Furthermore, it must be possible to calculate and optimize the consumption of alternative fuels under various operating conditions to ensure navigation with the lowest actual energy consumption. Finally, based on these technologies, route planning and port optimization should be possible considering alternative fuel supply chains, port situations, and GHG reductions. In conclusion, I think the development of digitalization technology focusing on decarbonization technology should be considered for effective environmental protection and effective GHG reduction. Thank you for your attention.